Hello, I'm teacher Ivan from Winner Educational Services. I'm here to take you through A-level pure mathematics, and we shall specifically be looking at how to solve simultaneous equations with three unknowns. This can be solved using various methods, but we shall look at basically three, that is elimination method, substitution method, and row reduction to echelon. We shall start with elimination method, solving simultaneous equations by elimination method. Let us go through this example together and see the steps that are followed when solving simultaneous equations using elimination method. The question says, solve these simultaneous equations using elimination method. We have three equations having three variables, x, y, and z. So our first step as we solve the simultaneous equations is first of all naming these equations. We shall give them 1, 2, and 3 so that we can easily identify them. After naming them, we shall consider any two of the three and decide which variable to eliminate from those two equations. That is to say, if we are to eliminate x using equation 1 and 2, that is eliminating x from equation 1 and 2. These are our equations. This is equation 1, this is equation 2. So if we are to eliminate x, then we must make sure that the x we are eliminating in both equations has the same coefficient. So the first step is to ensure that x is having the same coefficient. That's why we multiply 3 up, because we have it here, so we shall take it up, and the silent one comes down. So we interchange the coefficients on the variable we want to eliminate. Say the 3 goes up, the silent one comes down. And these constants that we are interchanging, all the coefficients we are interchanging must multiply through all the terms in a given equation. That is to say, the 3 will multiply x, 4y, 4z, and 7 to get 3x plus 12y plus 12z equaling 21. So after ensuring that x has the same coefficients, therefore we shall subtract equation 1 minus equation 2. When we subtract it here, we shall get 0. That is 3x minus 3x gives us 0. Then 12y minus 2y gives us 10y. 12z minus 2z gives us 10z. And 21 minus 6 gets us 15. So our newly formed equation is 10y plus 10z equaling to 15. But this equation is having only two variables, that is y and z. So we shall first of all divide through by the common factor, which is a 5, to reduce it to 2y plus 2z equaling to 3. And we shall name this equation 4. We shall also do the same considering equation 1 and equation 3. Remember, in the first case, we considered 1 and 2. So here we are going to consider 1 and 3, or we can also consider 2 and 3, meaning we take one of the two we have used up and the third one. So we are considering 1 and 3 in this case. That is to say, if we are eliminating the same variable just like we have done in the first case, meaning that we are eliminating x. So we must ensure that the coefficients on x are the same by interchanging the coefficients and we multiply through. So when we do that and subtract, the x will reduce to 0 and we shall remain with 30y plus 34z equaling to 49 as our equation 5. So meaning that now we have equation 4 that has y and z, and also equation 5 that has y and z, meaning we have reduced the 3 unknowns to 2 unknowns. And therefore, we are going to be considering the two equations, that is equation 4 and equation 5. So we are going to choose still one of the two, either y or z, to eliminate, considering the two newly formed equations 4 and 5. So for this case, we are eliminating y from equation 4 and 5. Still the same procedure holds. That is to say, if we are to eliminate y, then we first make sure that y is having the same coefficient in both equations. That's why we are now multiplying this by 15, since it already has a 2, meaning that 15 by 2 gives us 30, just like in this equation 5. So 15 multiplies through all the terms in the equation to end up with 30y plus 30z equaling to 45. And we subtract after ensuring that y has the same coefficients. When we subtract, y will reduce to 0 and we remain with 4z equaling to 4. So when we reduce by 4, we end up with z as 1. So you see that we have reduced until we remained with one variable, which is z. And that gives us the equivalent to z. So after getting z, now we shall substitute in one of the two equations, either 4 or 5, to get y. So we shall, in this case, substitute in equation 4. So from equation 4, which says 2y plus 2z equaling to 3, when we substitute for z, we shall end up with y as a half. Now that we have the value of z and y, we also need to look at how to get the value of x. So we shall now go back to the 3 equations that we had initially in the question. We pick one of the 3 and substitute for y and z in order to get x. That is, we are considering equation 1. So when we substitute in the equation 1 for y and z, we shall end up with our x as 1. So x is 1, y is a half, and z is 1. That is how we use elimination method to solve simultaneous equations with 3 variables. So here is a trial question for you to go through the same procedures and see if you are to get the very answers that are given to you. Otherwise, as you try out, don't forget to subscribe to all our YouTube channels. We have TikTok accounts. We are on Facebook, Instagram, and X. Just search for Wuna Educational Services on all the social media platforms. We are also having a website where we upload learning and teaching materials. Just search for wunaeducationalservices.com and enjoy our digital library. Otherwise, I'm teacher Ivan from Wuna Educational Services. Hope to see you for the next lesson. Bye-bye.